All right, let's go straight into reviewing. Question 1 asks us to look at the table of values for these two functions. So I got f, I got g. If I take a look at f, this it's 1, 2, 3, 4, 5. As you can see, it is being multiplied by 3 each time. So if you're multiplying by 3, that means this is an exponential function. It's increasing at an exponential rate. And if you look at this other one, it's like it's exponential, except the x and y values are switched. Well, the x and y values are switched, meaning it's the inverse. The inverse of an exponential is a logarithmic. And here they're multiplying by 5 each time. Well, take a look at f of x. That's the exponential function. Oh, that's 3 to the x. Cool, because I'm multiplying by 3 each time. Now, g of x would normally be 5 to the x, except since it's the inverse, it's a logarithmic. Therefore, it's just log base 5 of x. Yep. So if x is going up 1, 2, 3, 4, 5, and then the y values are going crazy, that's exponential. But if they've switched the x and y values with that pattern, it's a logarithmic. That one's not too bad. This is my least favorite question here. So below are the key features of a graph of a function g. That is the transformation of this function log base 3 of x. Now, log normally looks like this. Log base 3 of x. If you don't remember what it looks like, you can also look at it in the calculator. Right? So log typically has an asymptote at x equals 0. It has an x-intercept at the point 1, 0, and it just kind of goes off. And we're going to look at what happens here in this case. Well, the domain for log is usually x greater than 0, but the domain is x is greater than 2. Range is still the same. Log is usually increasing, but this time the function is decreasing. The asymptote has moved from 0 to 2. The x-intercept has moved from 1 to 3. So you see this number 2, 2, 2. There's all of this signifies some kind of a movement of 2. So this is definitely moved to 2 to the right. There is a translation that has occurred. Translation 2 to the right. So this graph has definitely moved 2 to the right. Not only has it moved 2 to the right, there's one more thing. It says it's decreasing instead of increasing. Since it's decreasing, it means the graph has flipped over. So there has been a reflection over the x-axis. Over the x-axis. What am I doing? All right. So I picked up all these transformations just by looking at what changed. The domain has changed. The function is now decreasing, so it's a reflection. Everything has moved over by 2. The hard part here is now running the rule. Well, actually, I think the transformations were pretty hard. But for this rule, it's basically log base 3 of x with a few changes. Because there's a reflection, I need to put a negative, first of all, negative log base 3 of x. I also need to account for the 2 to the right. So I put minus 2. Remember, whenever you have a plus or minus with the x, it always moves contrary to what you would think of. Minus 2 is supposed to be 2 to the left, but it means 2 to the right. This happens with all types of functions. It's going to keep following us. Right? Here's 2. Moving on. All right, so 3, we're going to be filling the blanks. So this is pretty much the same type of question as the other one. It's just that you need to identify the transformation from the equation rather than just the graph. All right, so this is a dilation by a factor of blank with respect to the blank, a translation of blank units blank. The easiest one is translation. There's a plus 2, so that moves it 2 up. So it's a translation of 2 units up. The harder part's the dilation, so it has something to do with 5. So since it's multiplying with the x, we need to think about it horizontally. Remember, whatever happens with the x values ends up going contrary to what we would like. So it's not really 5, it's dilation by a factor of 1/5. So this moves horizontally. If you think about horizontal, what's in the center of what's horizontally in the center of a graph? Well, that would be the y-axis. So it's a dilation by a factor of 1/5 with respect to the y-axis. If it's a dilation by a factor of 1/5, that means the graph gets thinner. So the original graph might look like this. It's going to look something like, what's plus 4? So the original graph's going to look like that. And then after the dilation, it's going to be even closer. So with the y, it's like it got closer to the y-axis. Everything gets closer to the y-axis here. All right, and then for this one, transformations that produce this one, let's think. Well, again, it's another dilation, but instead of being multiplied to the x, I'm multiplying to the whole function. That's called a vertical dilation, meaning it's getting taller. So this is a dilation by a factor of, let's think, dilation by a factor of, by 5. Why did that take so long? 5 with respect to the x-axis. Because when you have here, it would get taller with respect to the x-axis. So right here, translation of something units blank. So remember, -2. Oh, it's just like the other problem, right? The other problem had a -2, which means it was moving 2 to the right, not 2 to the left. 2 units right. So to summarize, if there's anything that happens with the x, it goes contrary to what you would think. Instead of going left, it would go right. Instead of being increasing by a factor of 5, it would be 1/5. But whenever it's in the front, it's usually the same. It goes with what you would expect. All right, moving down here. All right, for 4 and 5, we're going to solve each equation for t. So with number 4, first thing I would do here, I have 6e to the 5t. I also have 3e to the 5t. These are considered like terms because they both have that e to the 5t part. So I would just actually subtract from both sides, e to the 5t. It's better to subtract the smaller number than the larger number. So it's, get rid of the 3, not the 6. All right, 6 minus 3 is 3e to the 5t again, plus 100 equals 300. All right, well, now I got to get rid of the 100, subtract 100 from both sides. 3e to the 5t equals 300 minus 100 is 200. All right, next, I have to get rid of the 3, so I got to divide both sides by 3. E equals 200 over 3. Oh wait, look, I made a mistake. It's not 300. It should be 1,300. So that should be 1,200. Oops. So 1,200 divided by 3, that's e to the 5t equals 1,200 divided by 3 is 400. Now, I need to get rid of this e. We remove e with an ln. So I'm going to be putting an ln on both sides. So ln e to the 5t equals ln of 400. So remember when ln and e interact, cancel each other out. So I'm left with 5t equals ln of 400. Finally, I divide the 5. And t equals ln of 400 over 5. Most of the time, you could totally leave your answer like this. However, it does say, oh wait, no it doesn't. It says your answers may be exact, so you could leave it like this. Or correct to at least 2 places after the decimal point. So if we want to make an approximate using a decimal, we have to plug this into the calculator. So that would be, what was it again? ln 400, close the parentheses, divide by 5, and I end with 1.198. It only asks to 2 decimal places, so this would round to 1.19, but it would round to 20, 1.20. So you could have left your answers like this, or you could have gone here. It's probably safer to just leave your answers like this. All right, let's look at the one underneath. This one has a 10. So first thing I got to do here is get rid of that 5. Divide both sides by 5. Bam. 10 to the 3t comes down. 425 divided by 5, that is 85. I just did that in the calculator beforehand. How do I get rid of that 10? Well, I can't use ln. ln is only allowable for e. For 10, you would use just log. Remember, if there's no base on the log, the base is assumed to be 10, which is why I can use regular log. All right, my parentheses are a little weird looking. The logs and the 10s will cancel out, leaving 3t equals log 85. Then I divide both sides by 3. T equals log 85 divided by 3. You could totally leave your answer like this. This is considered the exact answer, or you could provide a decimal approximate. If you did, the decimal approximate would be 0.64. And then again, how would you do that? You just put log 85, close the parentheses, divided by 3. Yep, 0.643, which is round down to 0.64. Right? So the solving part's not too bad. All right, 6 and 7, we got to use this graph. They've also given us a function right here. So they want us to know what is the average rate of change on the interval from 3 to 9. So average rate of change formula, you don't need to memorize this. This will be given to you if you don't remember it. A over B minus A. Now, it wants the average rate of change on the interval from 3 to 9. So 3, the point is somewhere there, though it's kind of hard to tell what it is. And then 9 is up here. Also hard to tell exactly what this is. So the best way to find these actual values are to put this into the calculator. You can plug the numbers in, or you can just use second table to quickly get your answer. So that's 4 parentheses 3 to the power of x over 5. Like that. So remember, that's an exponent. If you notice, the x and the 5 were unusually small. All right, so you don't want to graph it. The graph isn't, well, I guess you could graph it, but it just looks like as unhelpful as this graph here. So I would go to second in table. So it wants me, I want to find what happens at 3 and at 9. So, oh look, at 3, what do I get? 7.7329 through 7. And at 9, I get 28.899. So I can use those two values to get my f values. So this point is 3, 7.733. And this one is 9, 28.899. So now I can use this for my average rate of change formula. Remember, 3 is your A value, 9 is your B value. That's why I was using 3 and 9 in the first place. Now let's actually apply this into the formula. So f of B, which is f of 9 minus f of 3, all divided by 9 minus 3. F of 9 is, well, I found it, 28.899 minus 7.733. All right, 9 minus 3 is 6. You don't really have to write all the work. You could just put it onto your calculator in one go if you know exactly how to put it in. But if you subtract it, that's 21.166 divided by 6, which is approximately 3.528. So there's my average rate of change. Right? Lovely. Number 7 is a little bizarre. For what x value is the function f of x equal to g of x equals 9 over 8 times 2 to the x over 2. So this is very bizarre looking. What it's actually asking is this. It wants the fraction 9 over 8 times 2 to the power of x over 2. It's too annoying, in my opinion, to try and solve this equation, especially because I have to set this one equal to the one from up there because it wants to know when are they equal to each other. So best bet is to just put it in the calculator and find the point of intersection. Oh, thankfully I already put in my first one because I wanted to be lazy with the table. So my second one is parentheses 9/8, close parentheses, multiplied by 2. You don't even have to put a times. You can just kind of put the 2 there and it'll do it for you. To the power of x, where's x? X over 2. Right? So we're going to graph it. We want to find where they cross. Here's the first one. Oh, they cross much higher. So you cannot find the intersection if you can't see it on the graph. You need to actually be able to see it. So let's go way higher. So the maximum of this graph is usually 10. So let's press the window button and change the y maximum to, how about 30? Still not quite high enough. Let's change it to 50. Also, I might change my scale just to make it nicer. Let's just make it 5. You don't need to worry too much about the scale. Oh, it seems they cross right around there. So let's try it. Second trace, which we'll calculate. I want to get to the intersection. Now, to be honest, with most calculators, honestly, with most graphs, if they intersect one time, you don't actually need to move the curve. You can just kind of press enter. I'm just going to press enter, enter, guess doesn't matter. Oh, wait, no sign change. I think I need to go a little further. So let's change the maximum to maybe 15 so we can see it a little better. There we go. So now you have to actually be able to see where it crosses. And I'm just going to press enter sort of wherever. There you go. Intersection's at 10 and 36. So it does cross at 10. So the answer is x equals 10. So yeah, you have to play around with your window. You may encounter a few errors, but you want to make sure you see it actually crossing. Otherwise, you will get an error like I did. So the answer is 10. So for what x value? X equals 10. And how'd you do it? Use the calculator. Oh, I actually don't want to say use. Found point of intersection in the calculator. Point of intersection. Okay. That one's ugly. And now for the last one. Now this is a Newton's law of cooling problem. So they've given you the formula. They've told you exactly what you need to put in it. Right? They gave you all this info. You just need to use the formula. So they're probably going to give us the numbers to plug in. You just need to be able to read the question. Ernesto brings a bottle of soda home from the market. He would like to have a cold glass of soda, but doesn't want to put the ice in the glass as it would water down the soda. He decides to cool it quickly by putting the soda in the freezer. The initial temperature of the soda is 76 degrees Fahrenheit, and the temperature of the freezer is 2 degrees Fahrenheit. The decay constant is K equals 0.04. So using the information, we're going to write a function for T. So we're just going to use the equation above. So T of T is just the name of the function. They've given it to us. I need, let's move this recording thing over. TA, that's the ambient temperature. That's the temperature of the surrounding air. That is 2 degrees Fahrenheit. So that's a pretty cold, decently cold freezer. I would prefer 0 to be actually freezing. 2 plus T sub 0 is 76. Minus, according to the formula, T of A again, which is 2 e to the negative k. Well, k is 0.04, so negative 0.04 t. I could leave the formula like this, but to be honest, 76 minus 2, why don't we just do it? That is 2 plus 74 e to the negative 0.04 t. I'd rather use something where I have to type less than type more. All right. It wants to know what is the temperature of the soda 7 minutes after he immediately puts it in the freezer. Oh, so just plug in 7. You have the function, plug in the value. T of 7 equals 2 plus 74, e to the negative 0.04, and you're multiplying it by 7. So I'm just going to find the value. I know I'm going to get a decimal, so I'm putting the squiggly equal sign. Let's get this out of the way. So I should be getting 2 plus 74 e to the negative 0.04. You don't really have to put the first 0. Times 7. There you go, 57.927. Right? I'll just put 3 decimal places to be safe. So the answer is 57.928 degrees Fahrenheit. All right, that's it. Cool.